You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. When the Earth's magnetic field flips. When the alternative science community began predicting a global apocalypse in 2012, some placed the blame on an unexpected reversal of the polarity of Earth's magnetic field. This, they said, would cause unprecedented superstorms, volcanoes, and earthquakes, and would put an end to human civilization as we know it. The newspaper Salem News said,
NASA has been warning about it. Anything can happen. And what normally happens is that all hell breaks loose. Magnetic polar shifts have occurred many times in Earth's history. It's happening again now to every planet in the solar system, including Earth. With the field weakening and cracks emerging, the death rate from cancer could skyrocket.
The metaphysics and pseudoscience website Gaia claims that recent dolphin and whale beachings were caused by an imminent pole reversal, which causes, quote, great disruptions for life on our planet, end quote. But not to worry, they offer a paid video called Flower of Life, promising to yoga you out of this mess. InfoWars says scientists are baffled by an impending field reversal and warns,
"We do not currently know when this will happen next, but it will have dramatic consequences for humanity when it does."
And also,
if the massive magma flows caused tectonic binding and the whole thing got out of balance like a washing machine, we could have a shift in the geographic poles, and then humanity would not survive the ride.
The police state conspiracy website Natural News trumpeted the headline, Earth's magnetic pole shift unleashing poisonous space clouds linked to mysterious bird deaths, and advises the following steps in preparation for the magnetic pole reversal.
Prepare, study, and practice a disaster plan. Equip each member of the family with a bug-out bag. Draw up an emergency contact list. Plan and practice an escape route. Get your finances in order and start saving cash. And exercise and stay physically healthy.
It's like you're going to need to start fighting zombies tomorrow. Are these steps truly the most rational response to the idea of a magnetic pole reversal? Today, we're going to see if the possibility of a magnetic pole reversal is actually a threat you need to worry about. A good starting point in this discussion is to examine exactly what the Earth's magnetic field is, and how and why it exists. Much of this is probably familiar to you, but a basic review can do no harm. We know that compasses point generally north, or close to it. The reason is that the whole planet Earth is like a gigantic bar magnet with one pole at the top and the other at the bottom. The reason for this is that the Earth's interior is mostly molten iron, which is rolling and churning with convective and other forces. These flows are governed by many different influences, including inertia, pressure gradients, buoyancy, viscosity, and thermodynamics. And since the Earth is rotating, the Coriolis effect attempts to force these currents to spiral, which results in the flows lining up with one another to be more or less vertical within the Earth's interior. All this movement of liquid iron creates electrical currents, and that Coriolis-induced vertical alignment of the flow turns the whole planet into one enormous north-south oriented electromagnet. This whole self-sustaining system is called the geodynamo, and it's governed by a science called dynamo theory. There's quite a bit of entropy in the system, of course, so the magnetic pole is not always perfectly parallel with the Earth's axis of rotation. And this is why the magnetic poles are generally near the geographic poles, but not necessarily spot on. Currently, the north magnetic pole in the Arctic Ocean is about 3.5 degrees of latitude south of the actual North Pole, and moving about 55 kilometers a year toward Siberia. Fun fact, although we call it the magnetic North Pole, we do so because it's located in the northern hemisphere. Magnetically, it's actually a south pole, which is why it attracts the north point of your compass's magnet. So what about these reversals of the polarity? It doesn't mean that the flow of molten iron all comes to a stop and then reverses. Among all of these many convective currents with varying densities of magma, varying temperatures, and all straining against the Coriolis forces, occasionally the system stumbles and goes into a chaotic tumble. It's a slow-motion train wreck of turbulence that takes thousands of years, currents colliding and twisting around each other, until they finally resume their orderly vertical flow. Half the time, like a random flip of a coin, the newly formed alignment of currents is in the opposite direction of what it was before. The electromagnet has been reversed. So that's what happens and how it happens, but it still leaves a lot of questions. First of all, how do we know this? We know it because of the geological record. The single most extensive record of paleomagnetic activity is the Mid-Atlantic Rift, which is constantly spreading open, bringing up fresh lava which flows out over the seabed. Ferrous minerals in this lava align themselves with the Earth's magnetic field, and as soon as that lava cools and solidifies, it leaves an indelible record of the magnetic field's strength and direction, while simultaneously telling us its age. This type of measurement is called magnetostratigraphy. The Mid-Atlantic Rift gives us a 40,000 kilometer long, detailed, calibrated, and indexed magnetostratigraphic history of the Earth's magnetic field. This record is corroborated by all the other places on Earth where we take the same measurements, many of which give us even better fidelity of data. By simply taking core samples, we know when and how often the Earth's magnetic field has reversed, how long each reversal has taken, and what the magnetic field looked like during those reversals. There's no guesswork involved. The record is right there, frozen in stone. We can also see what happens to the Earth's magnetic field during these multi-thousand-year turbulent reversals. Much like what would happen if you cut a bar magnet into segments and jumbled them about, the main north and south poles lost their intensity as other poles appeared around the globe. It's all very slow, very gradual, as all that turbulence takes place underfoot. But from the perspective of the surface-dwelling compass owner, all that could be perceived was that poles would gradually appear in different places, move about over centuries or millennia, and then lose their intensity. Many of them, at different polarities and random points all around the planet. And then, eventually, a strong northern and southern pole emerge victorious as the others all fade away. This is what the record in the rocks tells us has happened, and the activity also matches what our mathematical modeling shows. Simulations in computational fluid dynamics accurately illustrate this deviously complex shattering and rebuilding of the geodynamo. Now, this happens a lot, and the timing is random. In the past 83 million years, the records show 183 polar reversals. That's an average of every 450,000 years. But the duration of periods between reversals, called crons, is at least as random. But even more often than complete reversals are periods when it went a little crazy but then recovered, as if the turbulence in the mantle was enough to disrupt the normal flow, but little enough that it was able to recover. In these cases, the record shows excursions by the poles, but they return after only a few centuries, sometimes even faster. A very few times in the geologic records are stable periods which lasted more than 10 million years, and we call these supercrons. But the question many of you are asking is, how long ago did it happen last, and when can we expect it to happen again? Well, the most recent reversal happened 780,000 years ago, which is longer than the average cron, but still typical. No data whatsoever predicts how long our current cron might last. It could be a 10 million year supercron, or the stumbling blocks of turbulence might already be throwing monkey wrenches into the machinery of the stable flow beneath our feet. We don't know at all. And with the reversals taking thousands of years, it's improbable that either we or our descendants over the next several generations would be able to detect any change in progress. Today, some point to signs they claim indicates the next reversal has already begun, The fact that the pole is currently moving faster than usual, and the fact that the field strength has shrunk by about 10% over the past century and a half or so. While these are true, they do not support any conclusions. The poles have always moved, and while our field strength has dropped a bit, the level it has dropped to is about average over all of history. There are a few relatively large anomalies around the world, which some claim are those little poles that appear intermittently during a reversal in progress. However, the Earth has always had such local anomalies. The field has never been perfect. So in point of fact, there is nothing unusual going on with our magnetic field, and nothing that could be reasonably described as evidence of a change in progress. So when a reversal finally does happen, is it going to cause worldwide destruction? The short answer is a definitive no. Looking at all the mass extinction events in history, we find no correlation whatsoever to the record of pole reversals. Similarly, when we look at all the major climate shifts in history, we also find no correlation at all. Without any doubt, magnetic pole reversals have no impact on climate or life on Earth. Some people point to magnetotactic bacteria, which are hypothesized to use magnetic crystals to help them navigate along flux lines to find water with higher oxygen. It's improbable that these would be impacted. The flux lines will never go away. They'll just slowly reorient over a period of centuries. Others point to other species of animals supposed to use magnetic flux lines to help them navigate, like salmon or homing pigeons. Well, these theories are controversial at best, and plenty of studies refute the claim that the species have any significant reliance on magnetic flux. Their other senses play a far larger role, which is part of why we find no correlation between extinctions and pole reversals. We took a much deeper dive into this in episode number 523 on bird navigation. The sheer number of pole reversals documented over the past few million years is pretty good evidence that they don't have a significant impact on life on Earth. The problems most often touted that could result from a pole reversal pertain to the fact that the Earth's magnetic field provides protection from solar radiation. Without this protection, not only would electronics get fried, but people and animals would suffer from lethal radiation. Evidence from the paleomagnetic record tells us that this too is highly unlikely to ever present a problem. Never in the record has the planetary field ever disappeared. During a chaotic reversal, the magnetic field is shaped differently and it changes, but it would always be there in some form to deflect the solar radiation. It is true that if it took an unusually large dip in its strength, increased radiation would indeed result in greater incidence of skin cancers. But it's of little use for us to predict how humanity would respond to this, as it would happen many centuries in the future, at the soonest, and would provide many more centuries of response time. What other defenses would our race contrive against skin cancer during that period? We can scarcely even imagine. The same goes for the predicted threat to our power grid. It's true that if a dramatic loss in the magnetic field was sudden, giving inadequate time for a response, the world would indeed suffer tremendous disruption to all kinds of technologies, power, communication, and so on. But that's not the way these events work. On a timescale of hundreds or thousands of years, such systems would be re-engineered and replaced many times to newer and better standards over the course of a weakening of the magnetic field. Trumpeted scenarios of overnight disasters are simply factually wrong. There is no realistic threat to our power grid or other systems from a potential reversal of the magnetic poles. So please, do not panic at the idea of an impending reversal of the Earth's magnetic field. When it happens, it will not trigger a global apocalypse or pose any realistic harm to any of Earth's many systems. When you see a claim on the internet warning that it's coming soon and that we all need to become preppers, you should always be skeptical. A great big Skeptoid shout-out to premium members William Patrick, Aidan L. Chucho Barnes, Saber Wolfie, and Luke Neal from West Kirby, near Liverpool in the UK. Do you have your free Skeptoid-branded USB 3.0 thumb drive, preloaded with all the content we've ever produced? No? Then get it. It's just one of the benefits available to supporters of the show. To get yours, just log into the members portal at Skeptoid.com and set up monthly micropayments to help this content continue to be produced for the people who need it all around the world. The Skeptoid USB drive. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.